What are we gonna have to do on this one? There's gonna be a u substitution, and we can see that because we have an inside function up here. This exponent is a complicated exponent. We want to get rid of that. So what is our u gonna be? U is gonna be cosine t du. Not quite.
Cosine. Yeah.
So we're taking the derivative of cosine.
Negative sine.
Derivative of cosine is negative sine.
It's, so when we do the u, it's just the derivative for du.
Yep. That's all it is. Yeah, when you go to antiderivatives, you never fully escape derivatives. You still have, our techniques typically very often have derivatives in the technique itself.
And we're substituting because
We have something complicated that we would like to get rid of.
right, so if it was an e to the t, then no,
Then we wouldn't need to.
the things can would come down.
Okay. But what do we have to do with that negative sign there?
Move it to the other side.
Because we don't have a negative sign here, we're just gonna move that negative sign to the other side. Okay, so go ahead and finish this. Now that we have our substitution, go ahead and substitute in and finish it. So what does e to the cosine t become? That's e to the u. And sine t dt?
Negative, we'll do negative outside and then.
Negative du. And you can put the negative wherever you want, I tend to put it outside, so, yeah.
I thought we were gonna divide it.
We only divide numbers. We only divide the numbers here. Anything with the variable in it, we just want to leave there and hope that we have it available. So we don't want to divide the sine t over to the other side, but the negative sign we do.
So those sine t's cancel out?
So we're just replacing sine t dt. We're replacing this with this.
Oh, okay.
And what's the integral of e to the u?
E to the u.
U. And we have no limits of integration, so we need a plus c. And so then we substitute back cosine t plus c.
I have a question. Looking at this, could we have just skipped everything and just gone straight, since we know we can't, there's a divide? Could we have just said, does that make sense?
Well, how do we know that it's going to divide this out? I mean, how do we know that's going to go away? So that, I mean, that's where this part of it comes into it. So we suspect that cosine t is going to be a good u. But we still need to check this part of it to make sure that it matches this part of it. Okay, any questions here? All right, last one. Integral of x, cosine of x squared, dx. This was also going to be a substitution problem, so go ahead and do that.
zero, this is my -5, this is my number.
Yeah, except what's the derivative of x squared? But we just divide the number, not the variable.
Right.
Okay, so what's our u?
X squared.
U is x squared, because that's our inside function. Du,
2x dx
2x dx.
over 2.
But we don't have a 2, we don't want to do anything with the x, but we do need to get rid of that 2, because we don't have one. And so now those cancel. And so we're going to be left with
Cosine times, yeah.
cosine of u. And x dx becomes du over 2. And what's the antiderivative of cosine u?
Sine u.
Sine u. And then we substitute back in. And we get that.
Why is it 1/2 outside?
So this 2 in the denominator
Right,
here is with the du,
right.
but I just moved it outside. But it's in the denominator, so the 2
Oh, I
is
see.
saved. Okay. Any questions about any of this, about the final? Okay, office hours next Wednesday, which is our normal class time, so, but there will be students from other classes there as well, so it's just, so I will see you guys next Thursday for the final, or no, sorry, next week, Wednesday, if you choose to come to that, but then the following Monday for the final exam, so. Okay, I'll see you guys, on June 5th.
Oh, yeah. I gotta go to another class. I don't even want to go to. I think I have to go. No.
So I have 2 classes.
Fuck you, man.
And the other one
No, it's recording it. Tim,
is at 7:30 in the morning.
they ran out of film. They ran out of film. We're gonna have to redo it.